Good morning, good evening, good afternoon, whenever it is you're watching. Welcome back to Chemistry with Miss Hernandez. I'm going to be working on 6.15 periodic trends, atomic radius. If you are on your packet, if you have your packet with you, you're on page 19 to 23. If not, don't worry about it. Everything you need will be here. All right, so we are again working with fifth period. And who's going to be my volunteer? How can all of these people fit in such a small space? Help me out, guys.
I'll read it.
Awesome. Thank you, Oscar.
Events draw large numbers of people to them. Even an outdoor event can fill up so that there is no room for more people. The crowd capacity depends on the amount of space in the venue, and the amount of space depends on the size of the objects filling it. We can get more people into a given space than we can elephants, because elephants are larger than people. We can get more squirrels into the same space that we can people for the same reason. Knowing the size of objects we are dealing with can be important in deciding how much space is needed.
All right. So, if you have ever been to a concert, like a big concert, you have probably been in one of these crowds, right? Even if you've gone to like a baile, you know, you have probably been in a crowd this packed. Right now, these types of crowds are not happening because of the whole COVID situation and social distancing. But before COVID, you used to have all these concerts where social distancing wasn't thought of back then, right? We would go to concert and we would be literally crammed into the space, and we wouldn't care, right? Because there was no COVID situation. Nowadays, things have changed, right? Nowadays, you have to stay 6 feet apart from each other because you never know who has COVID. But and a lot of us have probably been to a concert or a dance where it has been this crowded. If you've ever gone to the livestock show, you've been in a crowd that might look like this. You might have even going in the hallways have been in crowds like this because the hallways at La Jolla High School can get this bad, especially the main corridors, right? The ones that goes across the building, not the actual hallways like A, B, C, and D, the corridors, the so you know what it's like to be in a big crowd like this, and depending on how big or how small you are, you can fit a different number of people. If you're talking in terms of elephants, like the introduction says, we're not going to fit as many elephants as we do people because elephants are very large. If you have squirrels, on the other hand, squirrels are a lot smaller. You can fit a bunch of squirrels in the same amount of space because squirrels just take up a lot less space than people, and definitely a lot less space than elephants. Now, why is it coming up in today's topic? Because elements occupy different amount of space depending on what element you're dealing with. If you're dealing with an element like hydrogen, well, that's a very small atom. It doesn't take up a lot of space as far as radius goes. If you're talking about cesium or rubidium or barium, those elements that you find at the bottom of the periodic table, well, those are going to have a lot more electrons. It's going to need a lot more space. Okay, so that is one of the reasons why it comes up today. Now, atomic radius. That's what we're talking about today. The size of atoms is important when trying to explain how atoms behave or compounds behave. One way that we can show the size of atoms is by atomic radius. Okay. And this data helps us understand why certain molecules fit together and why other molecules have parts that get too crowded um, in certain conditions, in certain temperatures, and certain pressures. The size of an atom is defined by the edge of its orbital, okay? And when we talk about edge of an orbital, we're talking about the circle that goes around the nucleus. This is an orbital. This is where you find your electrons, right? In the cloud, okay? And when we're talking about the size of it, we're talking about from the nucleus all the way to the edge of that orbital. However, orbital boundaries can get complicated. They can get fuzzy. In fact, they can change under different conditions. If you change the temperature, if you change the pressure, that can change the size of your atom. In order to make a standard measurement of the atomic radius, you usually assume that that element is attached to the same element. Okay, so it's like hydrogen bonded to hydrogen, right? And or chlorine bonded to chlorine. And when we compare it and when we bond it, that distance from the edge of the orbital to the nucleus is the atomic radius of that element. Okay? So the atomic radius, the actual definition is half the distance between the nucleus of identical atoms bonded together. So if this was hydrogen bonded to hydrogen, so you have one hydrogen atom, you have a second hydrogen atom, and here you have your nucleus. Over here you have your nucleus, and the distance that you have between them is the full distance. It's like the diameter of a circle, right? If you have a circle, the diameter meaning from one edge to the other, that is your diameter. The same thing can be considered here. The diameter between these two nucleuses for hydrogen, I think it says here that it's 74 picometers, right? Atomic radii have been measured for elements. The units of atomic radii are picometers, and that's equal to 10 to the negative 12 meters. As an example, the internuclear distance between two hydrogen atoms is 74 picometers, okay? So from this nucleus all the way to this nucleus is 74 picometers. We don't need that. All we are looking for is the radius. So we're going to cut that in half. The atomic radius of hydrogen is 74 divided by 2, which equals an atomic radius of 37 picometers. That's really, really small, okay?